Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 21 to 24 of the January 2017 Geometry Regents Common Core exam. All right, let's take a look at question number 21. It reads, in the diagram below of circle O, GO is equal to 8 and the measure of angle GOJ is 60 degrees. Question, what is the area in terms of pi of the shaded region? So what we're looking at here is the area of this shaded region, which is known as a sector, okay? A sector is a fraction of an entire circle. So let's go ahead and write down the formula for calculating the area of a sector. So let's write this down. The formula is as follows. Depending on the unit of the angular measure, that will determine what formula you're using, okay? So the area is theta, the angle, divided by 360 times pi r squared, okay? It's basically the fraction of the area. This is area right here. Theta over 360 is a fraction of the entire area. Multiply by the whole area, that will give you the area of the sector. And this formula is applicable when theta is in degree form. And that is the case here. As you can see, we have a degree measure. If you're dealing with radians, the area is going to be 1/2 r squared theta. Okay, so this is when theta is in radians. All right, so to solve this problem, we just need two pieces of information. We need what theta is, the central angle, and the radius, okay? So let's go ahead and find theta first. So you need to be careful with this problem. We're looking for the area of the shaded region. So we're looking for this area right here. So we need this angular measure right here. That's what theta is, the angle that you add to 60 to get 360. Okay, so theta is going to be full circle, which is 360, minus the angle we have, 60. So theta is going to be 300 degrees. That's the central angle for the shaded region. Radius r is 8, as given here. So our area is 300. So let's rewrite the formula again so we don't get it confused. Theta over 360 times pi r squared. So we already calculated theta to be 300 over 360 times pi times the radius square. Okay? Now if you divide by 0, between 300 and 360, you have 30 over 36 times a squared is 64 pi. Now 30 and 36, what goes into both of them evenly? 6 goes, right? So 6 goes here, 6, and 6 goes into 35 times. And then 6, let's say 2 goes into 6 3 times, and then 2 goes into 32. 2 goes into 64 32 times. So we just have 5 times 32 times pi. That will give us the area of the sector. If you do with your calculator, you end up with 160 pi for the numerator over 3 for the denominator. All right? So that goes your final answer for question 21. All right, let's look at question 22. It reads, a circle whose center is the origin passes through the point -512. Question, which point also lies on this circle? So one fact you want to keep in mind is the connection between points on a circle and the center, okay? So you want to recall that all the points that define a circle are what? Are equidistant from the center, okay? If you think about the definition of a circle is a locus of points that are equidistant from a fixed point known as the center. All right, so this is the idea we're going to be using to solve this problem. So the distance from the center to the extremity, to the circumference of a circle is known as the radius, okay? So R, using the distance formula, has to satisfy the equation x minus 0 square plus y minus 0 square, okay? So basically the distance, let me show you a sketch here. The distance from the center of a circle to a point on the circumference, that's known as r, okay? So when you use the distance formula within the context of this problem, because we have the origin as 0, 0, and at any point you can call it xy, and then you apply the distance formula here, that's how you end up with this equation, because we know that the distance d is the square root of x2 minus x1 square plus y2 minus y1 square. Okay, so we apply the distance formula to a circle centered at the radius. This would be the formula for computing the radius. Okay, all right, so we have a point that's given on the circle, so negative 5, 12 is on the circle. So what does that mean? Negative 5, 12 is on the circle. So x is negative 5 and y is going to be 12. Alrighty. So now this will help us compute the radius. So the radius r is going to be the square root of x is negative 5 minus 0 square plus the y is 12 minus 0 square. Okay. All right, now let's go ahead and compute what the radius is. So 5, negative 5 minus 0 is just negative 5. When you square that, you get 25. Plus 12 minus 0 is 12 squared is 144. You add that together, you have the square root of 169, which is 3. We have a radius, actually 13. We have a radius of 13, okay? Now, what's the deal? How do we know which one is correct here? Now, any point, based on our definition, any point on the circle, this circle that satisfies this condition right here, must be what? It must be 13 units from the center, okay? Hence, it must be a pair, an ordered pair. It must be a pair, any pair xy that satisfies the equation root x minus 0 square plus y minus 0 square. This basically helps you compute the value of the radius of a circle centered at 0, 0. This has to be equal to 13 in order for xy to be on this circle under consideration. Okay, so what we're going to do is test the different options that we have here and see which one works. So let me test option 1. So you test, let's test 1. Option 1 is what? 10, 3. So in this case, x is 10 and y is 3. Alright, so what we're going to ask ourselves is, does this ordered pair satisfy this equation right here? So we're just going to plug it in. Is the square root of 10 minus 0 square plus 3 minus 0 square, is it equal to 13? Alright, let's work it out. 10 square is 100, plus 3 square is 9. Is the square root of 100 plus 9, is it, for the question mark there, is it equal to 13? Is the square root of 109 equal to 13? That's no, this is false. Hence number 1 is not your answer. Now let's jump to the third one. Test 3. You can test the second one, but I'm just going to jump to the third one. Let's see what happens there. So for the third one, we have the ordered pair, 11 to root 12. Okay, so we have 11 to root 12, which follows that x is 11 and y is 2 root 12. So does it satisfy this equation right here? Let's see. So you have the square root of 11 minus 0 square plus 2 root 12 minus 0 square. Is it equal to 13? Let's simplify. 11 square is just 121 plus 2 root 11 square is 4 times 12. Is it equal to 13? Simplify this, we get root 121 plus 48. Is it equal to 13? If you add this together, you get 169. Is root 169 equal to 13? Absolutely. So our answer is option number 3.